Our prototype multi-touch mouse features a capacitive sensor on its top surface. The video on the top right corner shows the touch contacts as they are detected by the sensor. Each contact is shown in the user interface as a small dot around the mouse cursor. In the next part of the video, we demonstrate the 4 interaction techniques explored in the paper. In the MT mouse independent touches technique, objects are selected by touch. This allows the user to manipulate an object without clicking the mouse. Each cursor is completely independent, thus it is possible to select and move multiple objects at the same time. However, this also means that the user can sometimes inadvertently place one contact on an object when they meant to use 2, resulting, for example, in the object translating rather than rotating or scaling. With the MT mouse hover cursor technique, touches manipulate only the object under the mouse cursor. Touches that appear off the object still affect the currently selected object. To move an object, at least one touch is required. 2 or more contacts are required to scale and rotate. In the MT mouse click and hold technique, touches only manipulate the object when the mouse is in the clicked state. The current selection is determined by mouse cursor position. Manipulation continues as long as the mouse is in the clicked state. The selection is cleared on mouse up. In the MT mouse click selection technique, objects are selected by traditional mouse selection. The user positions the mouse over the desired object and clicks to select it. Touches then manipulate the selected object regardless of mouse cursor position. To move an object, the user must click and drag with the mouse cursor. The touch points initiate scaling and rotation only. The selected object may be changed by clicking on another object or cleared by clicking on the background. We performed a user study comparing these 4 techniques and 2 baseline input methods. With a regular 3-button mouse, the user may move an object by clicking and dragging the left mouse button, the right mouse button to rotate around the object center, and the scroll wheel to scale the object. For the touchscreen baseline condition, we use a laptop with a multi-touch capacitive touch sensor. This allows the simultaneous movement, scaling, and rotation of touched objects. Here we demonstrate a few docking task trials used in the study described in the paper. Each trial ended when the designated object is sufficiently close to the target position, scale, and orientation. Our main findings were twofold. First, the techniques with explicit activation and a single focus of interaction were faster and preferred by our participants. Second, the fastest and most preferred MT mouse technique was click and hold, followed closely by click selection. The most common grip performed by our subjects uses the thumb and ring finger to hold the mouse. Interactions are performed with the index and middle fingers. Subjects tended to either use both fingers simultaneously or hold one finger stationary while moving the other. Next is the pinch posture. Subjects held the mouse with the palm of the hand and the ring finger and performed the pinching gesture on top of the mouse with the thumb and index finger. One subject held the mouse with thumb and pinky and manipulated objects using the index and ring fingers with the middle finger stationary on top of the mouse.